video I'm going to look at applying the new exponent laws we have just discussed and using them to evaluate particular numerical questions. Recall the two key pieces that we have learnt in Math 10 is that if a number is raised to a negative exponent, then we need to take its reciprocal. In other words, we need to flip it. Looking at the first example here, 7 to the power negative 2, dealing with a negative, that simply means that it's 1 over 7 squared. So 7 to the negative 2 is just the same as 1 divided by 7 squared, which is, of course, 1/49. The second example is a little more complicated. 2/3 to the negative 4. Well, when we have a negative power, all we need to do is to flip it upside down. So 2/3 to the negative 4 is exactly the same as 3/2 to the plus 4. And 3/2 to the plus 4 is just 3 to the 4 divided by 2 to the 4, which is 81 over 16. But 81 over 16 is an improper fraction. The numerator is bigger than the denominator. So to write it properly, we need to make it into a mixed fraction. The main rule that we learnt in Math 10 was that if we have a fractional power, then the numerator tells us the power and the denominator tells us the root. So looking at this example, 81 to the 3/4, well, 81 to the 3/4 means that the power is 3 and the root is 4, so we need the 4th root. So we could take the 4th root of 81 cubed, which would mean that we'd first need to work out what 81 cubed is, and I certainly can't do that without a calculator. Or we also recognise that it's equal to the 4th root of 81, then cubed. Well, the 4th root of 81 is something you should know. The 4th root of 81 is just 3. 3 cubed is 3 times 3 times 3, which is 27. In the second example, 16 to the 1.25, well, we don't actually know how to deal with decimal powers, but I do know how to deal with fractional powers. So 16 to the 1.25 is the same as 16 to the 1 1/4, which is 16 to the 5/4. Of course, the 4 is in the denominator, so this means we've got the 4th root of 16 raised to the power 5. It's also equal to the 4th root of 16 to the 5, but I don't know how to do that. We should know that the 4th root of 16 is just 2, and 2 to the power 5 is 2 times 2 times 2 times 2 times 2, which, as I've written, is 32. Okay, so now it's time to actually apply these rules and use them to evaluate numerical expressions. So in this first example, we have 3 and 1/16 raised to a power. Well, I don't know how to raise powers of mixed fractions, so what I need to do is convert 3 and 1/16 to a improper fraction. So 3 and 1/16 is 3 times 16, which is 48, plus 1, so that's 49/16. So 49/16 to the minus a half is the same as, let's flip it, deal with the negative sign, so that's the same as 16/49 to the power plus a half. And you should recognize that to the power a half is the same as the square root. So this is the same as the square root of 16/49, which is exactly the same as the square root of 16 divided by the square root of 49, which is, of course, 4/7. So several little things going on here, but let's deal with one at a time. Convert 3 and 1/16 to something that we do understand, to a top-heavy fraction. Then deal with the negative power. Then deal with the fractional power and the root. So each bit can be done one at a time. You just have to be careful. Okay, in this second example, we have 9/25 to the power negative 3/2. Well, 9/25 is already a nice fraction. To the negative 3/2, let's deal with the negative power first. So all we've got to do is flip that upside down. So 9/25 to the negative 3/2 is the same as 25/9 to the plus 3 over 2. Well, this is a fractional power, so the numerator is the power and the denominator is the root. So this means the square root of 25/9 cubed, and it also means the square root of 25/9 all cubed, and that is the more obvious one to do for sure. So the square root of 25/9 is the same as the square root of 25 divided by the square root of 9, and we're going to cube that answer. The square root of 25 is 5, the square root of 9 is 3, so we're going to cube that, and that is the same as 5 cubed divided by 3 cubed, which is 125 over 27. 125 over 27 is an improper fraction. The numerator is much bigger than the denominator. So how many times does 27 go into 125? Well, you might need to use a calculator for that, but it's actually 4 whole times. 4 27s is 108. So we're left with 17 27ths, and that would be the proper way of writing the final answer. In this third example, it all looks decimal, but decimals are just a hidden way of writing fractions. So what is 2.25 as a fraction? Well, that's 2 1/4, and minus 1.5 is the same as minus 1.5. But 2 1/4 is not something we really know how to deal with. We can deal with fractions in an improper form. So 2 1/4 is the same as 9/4, and minus 1.5 is the same as minus 3/2. And now it's something we can deal with. First off, let's deal with the negative exponent. So 9/4 to the minus 3/2 is the same as 4/9 to the plus 3/2, and then we should recognize that the 3 is the power and 2 is the root, so this is the same as the square root of 4/9 cubed. We should recognize that the square root of 4/9 is the same as the square root of 4 divided by the square root of 9, and then we're going to cube the answer. The square root of 4 is just 2, and the square root of 9 is just 3, so the final answer is 8/27. And finally, perhaps the most complicated one, 5 1/16 to the minus 1.25. Well, again, let's make 5 1/16 into a fraction just as a simple fraction, top heavy. 5 times 16 is 80 plus 1, so this is 81/16. Minus 1.25 is minus 1 1/4. Minus 1 1/4 is the same as minus 5/4. So again, first off, let's deal with the negative sign, and we're just going to flip this. So that's the same as 16/81 to the 5/4, and then the 5 tells us the power, and the 4 tells us the root. So this is the same as the 4th root of 16/81 to the power 5, which I certainly can't do, and it's also the same as the 4th root of 16/81 all raised to the power 5. Well, the 4th root of 16/81 is actually the 4th root of 16 divided by the 4th root of 81, and you should recognize those numbers quite easily. The 4th root of 16 is just 2, and the 4th root of 81 is just 3. So when we raise that to the power 5, that is the same as 2 to the 5 divided by 3 to the 5, and you might need a calculator, but 2 to the power 5 is 32, and 3 to the power 5 is 243. Hopefully these examples have helped clarify exactly what to do when we're dealing with evaluating numerical expressions in exponents.